Welcome to the GIS 200 class project overview. The class project in GIS 200 is a basic habitat suitability model for the West Virginia northern flying squirrel. And we choose this particular species and this particular location and this particular type of project because it allows students to understand how you can use GIS to answer complicated questions. It helps students to understand how you can use GIS to potentially make decisions and how you can use GIS to generate information that doesn't exist otherwise, and how you can use GIS to uh, create geospatial models. And we're going to do a very simple model, but it is a framework and a concept that you can apply to a lot of different scenarios for a lot of different questions, and you can make it significantly more complicated, but at the core it still comes down to the same basic premise for how you structure a model, and that's what we're going to do. A lot of times people think of GIS as, well, I'll just map something. And um, that barely scratches the surface of what GIS is capable of doing. And so in this class project, we're going to make sure that everyone realizes what you can actually do. And you're going to look at this and think, oh, there's no way I can do that. Why are we starting this so early? Just relax. Recognize that we're going to help you, and we've done this before. And so we will periodically over the course of the semester do various components of your project. And all you have to do is do the things that we do when we do it during the semester and keep that data stored on your computer at home. And as you follow along step by step, section by section, when we do each part, you'll begin to complete the things that you need to complete. And at the end of the semester, your project will be done. Now, over the next several slides, we're going to look at the specifics of what this project will be as an overview, and then there will be another video that will be specific to the first part, and the first part will be the proposal, and it'll speak in more detail about that. But for now, we're just going to look at the whole big picture. And there's our obligatory flying squirrel animation. So all projects in the GIS classes should start out with some sort of a proposal. Oftentimes proposals are lengthy documents that detail a lot of information. The purpose of the proposal in the GIS classes here at Nova is to make sure that we understand what it is you want to do, and that we can sort of at least make an attempt to understand whether we think that's possible, whether you'll be able to pull together the things that you need to do, and whether we think that the project that you're proposing to do meets the necessary requirements in terms of complexity um, to showcase the skills that you should be learning. Now, much like the rest of the project for this class, the proposal is just an exercise in um, repeating what we're doing as a group, because we're all going to basically do some variation of the same project. And so your proposal will be well thought out and well explained, and you just have to write that up into a format. But here's basically what the proposal should be. It should be short, less than a page, double-spaced. There's no need for anything longer than that. The proposal has to do a few things, and we can do that all in well less than a page. And so here are the several key parts that you need to include in a proposal. The first one is we need some information that explains why this thing that you're doing matters. The second is you need to ask a question that's not easily answered outside of a GIS. Third, you want a very general description of how you plan to answer that question. Fourth, what data that you have or will use to do that with, and 5, what sort of products that's going to generate and how you will use that to make to answer your question or to make an informed decision. And so, literally, if you write a sentence or two about each of these, you've got a lengthy paragraph, potentially 2 paragraphs. I would rather you try to keep it all into 1 paragraph, though. So let's look at how we actually write the proposal. First step is to develop a good question. Now, what is a good question? A good question is one that's not too specific, but it's also not too general. You need to provide enough detail so it makes it abundantly clear what you're doing, but to make it broad enough so it doesn't narrow you down into too many specific things that could derail what you're trying to do. So when it comes to that question, you want to leave out as much detail as possible from the question. You can support that with additional information in sentences beyond that specific question. But in that question itself, don't try to come up with too detailed a description of what you're asking, because it may turn out to be a problem. Second, you're going to identify data, and I like to say no data, no project. For future projects, until you know that you can find the data that you want, don't even bother to write the question, okay? If you can't find the data that you need to do the thing that you want to do, then you can't do the thing that you want to do. So after this class, finding data for a project is the most single paramount thing that you can do. You have to do that first, because if you don't have data, you don't have a project. Now in this example, we will give you the data that you need for this project. The data is there. We'll show you where to get it and what to do with it. And so that'll help. The third step is you need to, in your proposal, sort of sketch out this model that you're creating. So once you know what the data is, you kind of visualize how this data is going to go together, how it fits to answer the question. And that's what we're going to talk about as far as like our methods and things like that. From sketching out that model, you really can go a long way towards explaining your methods and your products that you're going to generate. This is a really basic example proposal for this class and specifically for this project. So I'm going to read it to you, and then we can sort of discuss that just a little bit. The northern West Virginia flying squirrel was once considered at risk for extinction. This sentence basically is a way that we explain why this matters. Next, its numbers seem to have rebounded. We're again laying the background for why we're doing this. The Nat Geo channel wants to do a documentary on the species and asked us to identify their habitat across the state and identify the best counties to look for them. So someone has approached us with a problem that matters, and we know why it matters. Next, we propose to answer the following question. What counties in West Virginia have the most flying squirrel habitat? So now we've got a clearly defined question. So we started out, background information, why we're doing this, why it matters, who we're doing it for, asking a question, and then what's next? We'll be talking about our data and our model and what we're going to do. So to do so, we will model their habitat from elevation and land cover data. Right now, we know exactly what data we're going to use, elevation and land cover. We have, in the most general sense, explained our methodology. We're going to model the habitat. And then what are we going to do with that? We're going to make maps of the habitat and the total area by county. Thus, Nat Geo will have maps of habitat in the 3 counties with the most habitat. That would then, obviously allow them to target locations where they want to set up to shoot their TV show. This is all the information that I would need for a proposal. I can identify what you're going to do. I can, in the most general sense, understand what you're going to do. I can, in the most general sense, understand what data you're going to need and what you're going to do with it. And that's all. Now, if you were saying that you were going to use something like all the new issued building permits across the state of West Virginia for something, well, I know offhand that data doesn't exist. Too many counties have no zoning laws, and so to the think that you can actually find a geospatial layer of data across the state where that data doesn't exist because nobody has to do it in most of the locations would be a big indication that, hey, this project's not going to work. Now, if you would have upfront looked for that thing, you would have found the same conclusion. Yeah, I can't use that data. It's not there. And so a lot of times proposals, there's some back and forth where I say, yeah, this is good, I'm not so sure about this, you fix it, you get the perfect score. But for this purposes, this is a really clean, nice example, and you will write something similar to this in the next video. The second step in the process is the GIS stuff. And this is a really sort of a multi-step process. Begins with finding your data, which I'm going to tell you where it's at. You're going to download it and then fix anything that's wrong. And because until you have data that has been opened up and viewed in a GIS, you don't have data. Because a lot of times file names and download links seem like it's exactly what you're looking for, and then once you get that information, those files downloaded into your GIS, you realize it's not what you thought it was, or it's not what you need. And so finding it, uploading it, and then fixing anything that's wrong with it are the first steps. And this also folds into this idea of managing your data, creating a file structure of where you download, where you export, or not export, where you download, where you extract data, where you create files, where you store your maps. All of this is about managing your data, and it's all about knowing where you put things and knowing where things are. And ultimately, once you've got some sort of a file structure in place, you've found your data, you've loaded it up into a blank ArcMap document, seen what was wrong with it, what you needed to change, figured out what those fixes is going to be. You can then start with an empty blank map and start to set it up the way it needs to be to process your information. Next step is the model building, which is sort of the heart, if you will, of what we're doing. And so we'll look at things like concepts like how habitat suitability models work. Are we going to create an index model? Are we going to create a Boolean model? Are we going to create a regression-based model? There's lots of different types. Now we're going to do a simple Boolean model, which is a yes, no, true, false, 1, 0 kind of model, and that may not mean anything to you now, but it will in time. And essentially it's a model where you set criteria, and something either meets the criteria or it does not. And so if it meets the criteria, it's a 1. If it does not, it's a 0. And so what we're looking for is ways to combine the ones. We're trying to find locations that meet every criteria we have. And if it meets all of our criteria, it's considered what our goal is, or what we're trying to model, in this case habitat. We'll look at the various processes that would go into doing that. Specifically, what tool applies what process to generate that concept. So we're going to make a model. We've got to combine data. How are we going to do that? Some sort of an overlay function. What's the specific tools we're going to use? Is the process like map algebra? Is the tool like raster calculator? We work through this process and sketch everything out. Is it going to be something really complicated, or is it going to be something really simple? The model we're going to do for this project is going to be really simple. But the framework and how we do this could easily be switched around and made much, much more complicated for more complicated scenarios. Step 4 is just the final products phase of it, if you will, and it begins very simply by doing a lot of prep work. Once you've figured out all the steps and you understand what's what, and you've maybe run a few dead ends and backtracked and rethought some processes, and once you've kind of got it all figured out, the best thing to do is to then start over. Create a brand new folder, take your complete raw data, extract it into that location, try to keep a really neat and clean workspace in terms of your GIS in a new project. You've got an outline in your mind of what this thing's going to look like. You're going to redo all these steps, generate the new data layers that you need, and none of those dead ends, and you're going to keep things that you don't want or need out of your map document so that you can keep it just as streamlined and complete as possible. And ultimately, that'll lead to working on your poster, which is sort of the next phase in the process. This is where you take the time to finish up your maps and your tables that you're going to have. And your maps and tables are going to be a significant part of your final report grade. So you want to spend the time to make them look really good. And once you've got that set, you'll apply that stuff into a poster, and then start to apply the text that goes in the poster. And the text is going to be the front runner of what you're going to use to write out your report. And your report's the final product. And this is basically where you're going to sketch out what goes where, write it up, get your formats right, make sure you meet all your requirements, and add in all your maps at the end, and the project's done. So let's talk just a little bit about the poster. It includes information to explain or justify the project. It has multiple maps. It lists all the important outcomes that you come across in that modeling process. And you should always design your map to ask and answer a question. Okay? Not a map, a poster rather. And so this poster should, at the very onset, make me think, oh yeah, wonder what that is. And then as I read through your text and it refers me to the maps, it will then draw me through that process until I get to the end to where you have answered it in your conclusions. Now, the poster format will be provided. I'll give you a framework to work in. All you got to do is fill it in and add some flair or style or what have you to make it your own. You would have the option to go off and make your own formatted poster if you like, different than the basic one that I'm giving you. But what I don't want is for people to miss out on the points for the presentation because they don't know how to make a poster or don't know how to format one. And so I'll give you a format that you can work in that'll make it easy so that that won't be a problem. As far as the final report, it has the following sections. These are not suggestions, these are requirements. Every report will have an introduction, a method, results and conclusions, a reference section, and then a section of maps, tables, and figures. The report specifically will be 3 plus to 6 text pages. What does 3 plus mean? It means that the written heart of your report will exceed 3 pages. That does not mean 3 pages. It does not mean one line less than 3 pages. It means that the text of that report will run over into page number 4. Now, what not to do? Use giant, bold section titles like Introduction in size 36 font. Add spaces or extra points at the end or the beginning of paragraphs so that it stretches things out. You're already in size 12 font. You're already in double spaced. You don't need to add those extra things for the document. If you're adding them, you're only doing it because you don't want to write 3 full pages and you're trying to make a 2.5 page report you made into 3 pages. Newsflash, if it's not 3 pages, just go back and write more. Alright, talking about this 3 plus to 6 pages, only the introduction, the sometimes I'll slip up and refer to it as an abstract, so I left that in here as abstract. But it's a brief introduction. Your method section and your results and conclusions count towards that 3 to 6 page sort of range. When we talk about the body of the report, we're talking about the text in the middle. So after the cover page, when you're starting in that introduction and telling me what you're going to do and why it matters and asking a question, into the methods where you explain how you're going to do it, into your conclusions and your results where you tell me what all you learned and what it all means, that is what goes into that 3 to 6. Cover page does not count. The references, which immediately follow the results and conclusions, they don't count either. The maps and the tables, they don't count either as far as those page limits go. They belong at the very end of the report. One map, one page. Well, one map to one page. If you have multiple maps, you would obviously have multiple pages. and then following your maps, you would put your tables in there. You can put more than one table on a page. You just need to fit them however they fit. But again, it's at the end of the document, not in the body of the report. So your final layout would look kind of like this: cover page with your name and the report title. Nothing else. Next page would start the body of the report. That's your introduction. Couple paragraphs, 2 to 4. Tuck that GIS question into this section, along with an expanded rationale for the project, like, talk about the squirrels more and what they need. Um, you know, should we refer to squirrels by gender, or should we just call them squirrels? I don't know. So if I slip up and call them he's or she's, and that's not appropriate, I apologize. I'm not sure how squirrel gender should be spoken of in the vernacular. Um, the next section is the methods, and I'm listing here 1 to 2 paragraphs because your methods can be relatively short in a relatively simple model. They can be longer. Specifically, if you need to make the minimum report length, the method section is an easy place to go back and add more. So you've written these 1 or 2 paragraphs about what you're doing, and you need more length. Then go back and write additional paragraphs about things like the data that we used, where it came from, any limitations about it. If it, for example, land cover has a lot of different classifications, which classifications did you choose? What are the contents of those classes? You can easily milk a page or more out of that to add into your method section, so hitting 3+ pages won't be a problem. And then, of course, you can also talk about the intended products. Tell me about the kind of maps you are going to make. Your results. The key thing about results, remember, results are facts, not opinions. So results would be like showing a map of all the elevation data over a certain number. So if the magic number is 909 meters and you generate a map of the state showing all the elevation above 909 meters, and that data layer that you're using in that map would be part of your model to get to your final answer, that's great. You can make a map of that so that when you're telling me in your methods section or in your results section that you identified all that area within the state over 909 meters in elevation, see map 1 and then show me the map of the elevation. That's that kind of stuff. Your conclusions. The conclusions is basically the answer to the question. The model should generate the answer, but sometimes the model will generate a range of answers. So it may not pinpoint this is the best spot. It may show you that this is the best general area, in which case you may point out some place specifically that you think is a good choice. But if you do that, you got to support it with the facts, and ultimately your conclusions and the conclusions of people looking at your maps are not always going to be the same thing. So try to keep your conclusions as unarguable as you can, and to limit the amount of opinion as much as possible, and focus on what you can support with the facts that you've generated. So after the text pages, next will come the references. Now I'm not going to require any specific format for references because there's about 809 bajillion different kinds of formats for references. I'll give you an example of the one that I use most and the one that I prefer. I don't care whether you follow it or any other reasonable format for references, but you need to follow some format for references. And whatever format it is that you follow, it needs to convey the following pieces of information to the reader. And so at a minimum, any reference format that you choose should include the author of the particular thing that you're referencing, the year it was published, the title of the thing, where it was published. If it's something that we got from a web address, I want that web address, and the date that you last accessed that website. Because that's a way of, a lot of times you might access something on the web and then it's no longer there. The place that was hosting it took it down, what have you. Any number of things can happen. But if I see, well, you accessed it on this date and I check after and it's not there, it doesn't mean your reference is wrong. It just means it's changed since that time. After the reference page, you add your tables and figures. You won't always have figures, and you won't always have tables. A figure would be something like a picture of a flying squirrel or something like that. Or it could also be a map. But I prefer to label my maps as maps and my figures as figures. And as for tables, depending on the specifics of the question you come up with, you may have tables. Don't add any tables or maps in the text pages. They belong at the end of the report after the references. That's where all that stuff goes. Not earlier, not someplace where, it seems like a good fit in the middle of a page. It also makes it really hard to figure out if you've got 3 pages of text if you throw a bunch of tables and maps in the middle of it. But in general, when you're doing most sort of professional and scientific reporting, usually the maps and the figures and the tables, they're all provided at the end of the document. It's only when those publications become finalized in a journal or on a website or something like that that they start embedding those things in the text. And we want this in a report-like format so that they don't belong in the text, they belong after the text. Scoring. How's this going to break down? Well, the percentages for what these things do could change from semester to semester and from instructor to instructor a little bit. So I'm not going to say this is worth 10 points and that's worth 20 points. I'm going to break down the total report score into percentages. And so if it's worth 100 points, then it's 100 times these values. If it's worth 200 points, it's 200 times these values. But basically, if you're within this required length, more than 3, less than 6, that component, along with it being well written, in other words, your grammar and your logic and what you're trying to say and do is reasonably well. That's the things we're looking at there, and that's going to account for 20% of the total score. Next, we'll look at the introduction, and you got to make sure that you make the case for why your project matters and that it asks a clearly punctuated question. Now, here's a big hint. That means it should have a question mark at the end of that sentence. Now, questions should be simple and direct and broad, not lengthy, compound sentences, sentences with, weird punctuation and that kind of stuff. No, you don't want that. You want to boil that sentence down to something, boil it down to something very distinct, very clear, and very broad and obvious. So, a question like, how much flying squirrel habitat is in each county in West Virginia? Didn't say anything about how I'm going to count it. Didn't say anything about how I'm going to identify it. I just want to know how much habitat there is in each county. Didn't say what habitat is. I left all that up to other parts, and I just asked a simple question. How much habitat is in each county? Boom. Perfect one. And then, of course, the introduction needs to also provide some sort of an overview of what all you're doing. Like the scenario in the example, one that I gave about, being approached by Nat Geo to do a flying squirrel show. Methods. Again, describe the methods you use. I don't want specific steps, okay? You don't want to say things like, next we took the data set and added it into the raster calculator. Raster calculator is a specific tool. It's within a set of tools called map algebra, but map algebra is also sort of a big concept of how you can do things. And so what you would say would be, we overlaid the land cover and the elevation data set and used map algebra to combine these following Boolean reclassifications to generate an output layer of locations meeting all habitat criteria. Something more like that. You need to explain the choices that you make. Like when we're talking about the land cover, I chose this land cover, this land cover, and this land cover. That's something that you would say in your methods. Why? What is in those land covers? Those are the kind of things that you should include that'll make your method section significantly longer. Results and conclusions. Describe the various outputs of the modeling process. What did the elevation data look like? Discuss any types of maps, tables, and figures that you include at the end of the report. If you make 6 maps just to show me you can make 6 good maps, and nowhere in your report does it ever say see map 1, see map 2, what have you, it's like they don't exist. So you need to, when you're writing up your results and talking about it, you need to talk about the maps that you made, the tables that you made, that kind of stuff. And so if you've got maps and tables, you need to, when you're ready to talk about that, or after you talk about that in a sentence, put a little set of parentheses, and inside those parentheses write see map, and then 1, 2, 3, depending on what it is. Your maps, tables, and figures count for 40% of the total grade, and this is based on the overall appearance of the maps, their design, layout, and content, and understandability. And what does understandability mean? It means that you formatted your map in a fashion that it looks good, it functions good, it's easy to read and understand, it does everything that it needs to be. It wasn't some cheesy screenshot that you actually exported as a map and, did the kind of things that professionally you would be expected to do. Your references count 10% as well. Basically, you need to make that good faith effort to format your references in some reasonable way. They should make it clear who made it, developed it, or authored it, and have all those things that I asked for back when I talked about the references. And I just want to point out one last time here, a website that you download data from is not the author of the data. A lot of times we're going to get all this data from one location, the West Virginia GIS Tech Center. The GIS Tech Center did not make this information necessarily, and so where did it come from? Who is responsible for it? That's what you have to figure out when you write up your references. So that's about a half an hour's worth of explaining what you're going to do with the project. Next, there'll be a shorter video about writing your proposal, and then in a few weeks to a month or so down the road, we'll look at the next sort of step in the process where we go and get all of our data together and fix it. And then a few weeks after that, we'll actually work through that model process. And then we'll come back a little while after that and have one final session where we take the data and things that we generated in that modeling process, and we'll stick some stuff in a poster and talk about your report and that kind of stuff. And then you'll do your presentation of your poster in class. Basically, we'll do a Zoom teleconference, and we'll take turns sharing the screen where each student can show their poster and tell us about their specifics of their project. And then the following week will be your final exam. So that's the process in a nutshell. It looks large and daunting at times from the beginning, but know that we will, in great detail, go over every step of the entire process, and all you have to do is follow along to complete it. Thank you.